everyone, and welcome. It is Wednesday, and the crew has assembled. We have the Knowledge Bolide crew over here on this monitor, and we're going to be talking about things that fit in with us, the oddballs, the weirdos, the things you can't fit in any slot of reality. We're talking about ungrouped and anomalous tonight. So as we go through the night, you're going to learn a little bit more about what these terms mean, and we're going to give you some really good scientific information. We do have a VIP scientist in the audience who may chime in from time to time, but we're going to do this on our own as best we can. So I have some carbonaceous, a palisite, a chondrite, and an achondrite to show off today. So real briefly, when a meteorite is classified, the whole classification process is about getting a bunch of different types of rocks and putting them in piles that all match up and align with each other for a certain logical reason. Well, the reason that meteorites are classified is because of their geochemistry. So because of that, they can put them in different piles, different groups. Every once in a while, there's a weird one that doesn't fit in a group, and that's the ungrouped one. So we're going to talk about ungrouped today and also anomalous. Anomalous is a little bit different, and we're going to lean on honorary professor, we got to be specific today, honorary Professor Patty to explain to us and show us an anomalous sample and explain what anomalous means on this carbonaceous sample.
So anomalous, as it's generally used, is that a meteorite is quite similar to one of the existing classification groups, but has one significantly different thing. And sometimes that's things like chondrule size or oxygen isotope ratios. And so those are anomalous. And then way out in left field is ungrouped. And these are so unlike the existing groups that they don't fit in any of them, and so they're called ungrouped. Now, someday we may have enough of those to turn a grouplet into a group, and there's probably some exciting things coming down the pike for carbonaceous chondrites. And there's been some proposed grouplets in presentations at the Meteoritic Bulletin. But one of these ones we're going to look at here first is Chwichiya 002, which is a C3.00 ungrouped carbonaceous chondrite. I have to show off my Topher Spin scale cube that I hope Topher and Sue get some more made of at some point here. This guy is Chwichiya 003 or 002. For me, it ticks all the boxes. It is carbonaceous chondrite. It's a 3.00, so it means it's really not experienced any time under heat and pressure. And in fact, if you dive into the literature a little bit, there's multiple comments that this one was unaffected by heat and pressure to a greater degree than even Semarcona, which is one of the 3.00 ordinary chondrites. And the thing that makes this specimen special is that it is very crusted. It's got a small area at the bottom there that's uncrusted and kind of half of the other side without crust, but beautiful contraction cracks. You can see some big chondrules through the fusion crust. So Chwichiya is chemically different than the other carbonaceous chondrite groups. It has dramatically bigger chondrules, 480 micron average apparent chondrule size, and almost no CAIs. So it's really an odd duck. And it made my Tucson when Boris resold this one to me.
Yeah.
And then this little guy.
Wow.
I'm going to steal a little bit of Topher's thunder here. This is Oid Maya 003, a C3 ungrouped carbonaceous chondrite. And you can see kind of this one isn't ultra oriented, but you can see a bit of a rollover lip there and just beautiful fusion crust. And
That
that's what
is,
I had, Topher.
that's a beautiful example of one. I'm glad you showed off that one, but I have one I'm going to show off. You can actually see inside of it. So that
Ooh,
will be a little something for us. One thing to know about the ungrouped and anomalous is sometimes they look exactly like everything else, and the only way you can tell is by scientific testing. There's others that look so unique that the moment that you cut into them or something, if you're lucky enough to cut into one, and you look at it, your jaw probably drops like, what is that? So I'm going to show you my example of weed Maya 003. And then I also have one I'm going to show you that is an obvious, what the heck is that? Okay, here is my example. And I guess I lied to you guys because it's pretty much fusion crusted as well, guys. You really can't see inside.
that one's an interesting shape.
Yeah, it does have a lot of thicker fusion crust on the backside, but still has a remnant rollover lip. Yeah, beautiful example. And I have some notes about what makes this an ungrouped C3. It contains tiny, unequilibrated chondrules. 50% of it is fine-grained matrix, and that matrix is partly made up of CAIs, galenite, GEHLENNITE, spinel, and chromium-rich diopsides. So these were referred to as reflective minerals.
Sorry to interrupt. Refractory, it just indicates that they formed at a very high temperature.
Yeah, thank you, Pat. I appreciate you clarifying that. So yeah, this has a lot of science going for it, and this is actually where my weakness shows because I am not a carbonaceous guy. So I know I can explain very little about it, but I know that this is a very special and scientifically important sample that hopefully one day will get grouped with 4 or 5 others. All right, now we're moving into one that I'm a little bit more familiar with and a lot more in love with, to be quite honest with you. This is a super, super special chondrite to me. It was actually, where do I have it? There we go. It's my 10th anniversary present from my wife. Yes. So this
So
is super,
romantic.
yeah. Well, no, it's super, super cool, and it's actually showing really well. As you can see, there are chondrules in there. Now, those chondrules resemble unequalated L3/4 material. But when you look at the sample, you can tell immediately that is not your typical L, LL, or H. It is 75% nickel iron metal.
Oof.
So when they dig into it, the chemistry of the olivines plots L, the pyroxene plots H, the oxygen isotopes put it LL, and it doesn't fit into anything else. So this is an ungrouped metal-rich chondrite. And you can definitely see the silicate materials in there. But what a super, super special unequilibrated. Sue's making fun of me in the chat because I don't know how to
Oh,
say
like
words.
unequilibrated.
Yeah, so that's one that's really super special to me. Um, so it points to 3 different ordinary chondrite groups, and I think the thinking behind the creation or the geology of this is a chondritic parent body hit a metal parent body or vice versa. And it's kind of like you got your peanut butter in my chocolate, I got my chocolate in your peanut butter. There's a high concentration of metal and only a little bit of chondritic material that was left in this one, and it didn't remelt. It's still in that L3, L4 condition when it was done. So that's a super, super rare one to have that much metal in it. And you can tell right away by looking at it, like, what is this? This is something I've never seen before. Next, Anthony has some stuff, and it's a little bit more metallic than what I just showed. So we're going up a level now. So Anthony, you have two that you want to show. I'm going to let you do them both at the same time. They're both irons, but they don't fall in any group. What are they?
Well, they are officially classified as iron ungrouped. So make with that what you will. And let me just turn on my camera here for you. I am not the most science-based collector here when it comes to this stuff, so I'm not gonna try to get into the science behind it. I got these, and this first one I'm gonna show you is called Dronino. I got these because they look weird, right? In addition to being ungrouped, like on a scientific level, they're also just unlike most meteorites, iron meteorites. And you can see why. So, Dronino, I believe this texture is because of the terrestrialization. This was found in 2000, 2000 out in Russia by, I believe, some truffle hunters. So they were out there probably with like some dogs or something. I don't know. But they were hunting mushrooms and they found some weird stones. And, typically when you classify an iron meteorite, you take a slice and an etch, and it'll reveal a Widmanstätten pattern. And these are cool, also weird, why I like them, because they reveal no pattern. So I believe these contain sulfide inclusions, and then the kamacite and taenite are like those long strands, those elongated things, I believe. I'm not completely sure. Here's the other side. That's pretty cool. It looks like a painting,
Yeah. Yeah. Wow.
But, unlike any other iron meteorite, that's etched, like a slice of it.
Yeah.
Really cool.
You don't, if you look at it though, really, really super close, you may be able to see a micro Widmanstätten pattern on it. I do have some Droninos that they were, well, the meteorite luckily worked with us, but the polishing was done professionally, the etching was done professionally, and it actually shows Widmanstätten pattern in the background. It's super, super cool. It's wispy.
Yeah, that's really interesting because the next one I'm about to show, it's Gebel Kamil or Camille, It's often said that it has no pattern, but it's supposed to, right? So here's just a big hand specimen that I got. I really love it. It's a good representation of like that lizard skin or leather skin that it's often referred to. Um, and what this is, I believe the current thinking is that that is sand that got fused onto the rock. And it's usually just on one side, right? The other side doesn't have it. That looks like the side that was sheared off, from the shrapnel. And then this side has the cool texture on it.
Mm-hmm.
So it's interesting, which is why I got it, right?
Yeah.
And on the inside,
Can I bug you for a second?
sure.
If you look back at the top of that, it looks like there's damage on there. Is that an impact?
Here.
Yep. That scratch right there in that little divot just caught my attention. Does that look like an impact scratch?
I don't know.
Wow. All right,
Huh.
something to enjoy later with your eye loop, I guess, man.
Yeah, that's a good catch, though.
Yeah, yeah,
I don't
nice.
know. It might have to be because, God, to leave a scratch like that.
Yeah.
And then forgive me, this slice wasn't prepared very well.
Mm,
So it could probably use a little love here, but here's the Gebel Kamil on the inside.
yeah.
All right, so pretty blank, which is cool, but like solid, like no inclusions, no nothing. But it
And
should have a pattern, right? At least
yeah,
according to the Met Bull. Um, and that one was found in 2010 by some dude who was looking for old Egyptian settlements using Google satellite image searches, and he found a crater. And then when they went out to investigate, they found pieces of the meteorite. So cool little backstory there for you.
yeah. Thank you, man. I appreciate that. I'm gonna ask. I hope I don't have it backwards. They don't have they tend the attack sites, not the attack sites tend to be low in nickel, therefore they don't have a pattern. I believe that's an accurate statement. So I don't see anyone's head shaking, so I got away with it. Okay.
Well, actually,
Oh
sorry.
God,
Um,
Professor Pat.
the attack sites are very high in nickel. They're almost entirely taenite, which is the high nickel alloy of iron and nickel. When we see a normal nickel iron meteorite that has taenite and kamacite in it, the grains are of taenite and of kamacite, and when they cool very slowly, I believe the taenite crystallizes out first, and then the kamacite around it, and so that's what forms the Widmanstätten
Uh-huh.
pattern or Thompson pattern. Um, and so if all you have is taenite, then it just crystallizes out as one big piece, and you
Wow.
don't get to see the Widmanstätten pattern.
Thank you, man. I have a folder on this monitor over here, and it's called Learning Irons, and it's going to be a grand show when we get around to it. I'm just dumping all kinds of knowledge about irons in there, and some of my favorite things are pictures of iron meteorites, slices, fully fully finished, etched, with the pattern and everything revealed, inclusions and everything, with arrows going down to fine detail, explaining exactly what everything is. Because that's the type of learner I am. So if you guys are interested in seeing an educational one on irons, maybe you can leave a comment below and let me know if that's something I should spend my time on, because I'm interested in it, and we haven't really covered it necessarily except for our 101 series back in the day. So we may want to just boost that back up to the top. Talking about boosting back to the top, Chris Sanders in the house, and he has a really cool one to show, which is Check 002. It's the one that broke the rules. And then he has another one to show that's also an ungrouped achondrite. And hopefully I'm not gonna steal your thunder, but I had one interesting fact that Sue wanted me to bring up. She thought it was a super interesting thing that when she was doing her research, the research led her to a summary statement of pretty much every new ungrouped achondrite is another failed planetesimal. You have basically a parent body, a different parent body that didn't go anywhere because it's now in Chris's collection. How are you, Chris?
Potentially could be.
Potentially.
Yes.
Hey, thank you. Chris, how are you, man?
I'm good, brother. How you doing?
Very well.
So this is a slice of Check 002. So yeah, this one, I mean, I think the big claim to fame with this one you always hear is the oldest known magma in the solar system that we've gotten our hands on, right? And I don't think there's any two cooler words in maybe all of science than space lava. And that's kind of what we have here. So, I mean, my basic understanding is that for magma to form, you have to have some level of differentiation, right? So you have all this random junk in space, and one blob meets another blob, and that gives it a little more gravity, and that pulls in more blobs until eventually you get something big enough that you have heat and radioactive decay, and that causes things to differentiate. So the heavy stuff starts going towards the middle, the lighter stuff goes to the outside. That's how we get a core and a crust. That stuff eventually, the silicates there that have moved out get heated again, and they turn to magma. And then eventually that planet, as we talked about, perhaps fails or something smashes into it and it gets scattered all about, and that magma has at that point recrystallized, and that's how we get what we have here. That's what the little green specks we see here are. These are translucent. I might be able to show that. But yeah, space lava. What's cooler?
Yeah, there we go. That's the money shot. Yes.
And this one has some interesting, I guess, I don't know if that you would say they're different lithologies, but definitely, I mean, the textures of kind of the center area where you have all these kind of intersecting lines. And then on the other side, you have kind of more towards here, in this area, there, it's more like speckles or dots.
Chris, I was going to ask about that because I've seen quite a bit of Erdchech 002, and it's not as spindly as yours. If you go over on the right-hand side at 3 o'clock, like you were just pointing, that creamy little worminess, that's the familiarity that we're used to.
Yeah, absolutely. And I've seen very few pieces with both. I've seen some that look more like lines and some that are more like dots. This one had both, which is why, I'm only going to have one piece of Erdchech in my collection, and that's why I ended up with this one, because it had a little bit of everything as well as the translucency and all that. So I think it's always neat when you have a rock with a wild story, like being the oldest recorded magma that we have from the solar system, and it also looks really cool. Like sometimes it's one or not the other, but this is both.
Yeah, that's the story of carbonaceous.
Yeah.
You have another ungrouped. That's a beautiful slice, by the way. I can tell it's pretty big by your hand next to it. You have another ungrouped achondrite, potentially a failed planetesimal.
Yeah, I do. And this is NWA 16128.
Oh my goodness, man.
So NWA 16128, 2022, this is like a 31.5 gram piece found in Algeria. So it is an ungrouped dunite, right? So dunite, there's different words that are given to things based upon the amount of olivine they have. Over 90% is dunitic or dunite. I believe below that is peridotite, maybe. Someone knows more about that than me. But yeah, dunite. So this thing is mostly olivine. You see a lot of green and such around here.
Yeah.
Again, very interesting rock. That's not a hole in the middle. Let me have it catch the light.
Yeah, I was going to say that looks like it's a solid hunk of metal in the middle. Oh my gosh. That's crazy.
Wow. So is that impactor metal or?
Yes, and Chris, if I can answer that for you, I believe this is the one that was hit with the palladic impactor. So there's bits of this meteorite that actually have pallacite inside them.
There's some here, and these are little specks. The light isn't catching them well, how I've got this position, but
wow.
It could be used as a mirror almost.
it's very, very shiny.
Wow.
Let me throw the macro lens on for this scene. So yeah, so you can see there's just tons and tons of olivine throughout. This is that little metal blab. The lines in it, I believe, are just an artifact of the sanding, polishing process there. The kind of the spherical angle of that, right, as the pad spins, kind of gives that away. But
wow. We have mentioned a lot of things about this slice, but we've not really talked about the obvious elephant in the room. I mean, we got the wrong lens on now, but that is a massive inclusion we overlooked in the beginning. Like, look at that. That is gorgeous, dude. Wow.
Certainly one of those you could just spend a lot of time with the macro lens, just kind of going through and looking at all the different sections.
Wow. That's super interesting.
So I think I love an ungrouped achondrite for a lot of reasons. As you and Sue said, like it's probably some sort of planet that maybe existed at one point. And when you're talking about things that are differentiated and you have all these crazy geological processes, and we don't know how close or far away if they were from the sun. Maybe they were in the right area. Maybe something carbonaceous landed in the warm pool of water somewhere, and you had a couple single-celled things floating around that were maybe alive, right? So who knows? Like this could be you know, a couple billion years from now, someone could be looking at an Earth rock and they're like, "Oh, look at this ungrouped achondrite that 8 billion humans used to live on. They just don't know about it." So it's just crazy to think about.
Very cool. Thank you, Chris. I really appreciate you going into depth and pontificating about that. When people ask me what my meteorite goals are, I have a silly answer, but it's true. I hope one day to be in 4.6 billion years, I hope that my carbon is in some carbonaceous meteorite collection on Galaxy 14 Nebula 9. So I'll be their Earth carbonaceous and of course, ungrouped.
They're
So-
going to come up with a different word for you, Topher.
Anomalous. I have another achondrite to show you guys, and this is a super, super special one. I'm going to wipe off my fingers as well. The most enjoyable meteorite to learn about is one that you own. So this is, I say it, Widmanstätten 001. It is a anorthite-rich, ungrouped achondrite with diagonite affinities. So it plots with or has some similarities as diagonite, but it has so much anorthite that it cannot even be close. I believe a diagonite, anorthite-rich diagonite is in the 20 to 30%. This is in the 76%. So, and it's also a very easy recipe. There's basically 2 ingredients and just a little extra cosmic dust, but this is nearly composed of, and we can have a conversation with this about this after I'm done showing it off. Plagioclase. So it's nearly 80% plagioclase, and plagioclase is a almost pure form of anorthite. So that is the way I'm describing this. So I'd love to open that for discussion in a minute. And there she is. This is 17 grams, I believe. If you notice, the outside does have a very delicate layer of fusion crust, of greenish fusion crust on it. So it is a lightly weathered, very lightly weathered. And then when you look at the back side of it, it's one of the few almost white meteorites, and that's because of the plagioclase and northite.
I'd like to add that this exact specimen was on the cover of our very first calendar.
Oh yeah, nice. It's not like you can ask for a piece any size you want, so I had to get a bigger piece than I wanted because I wanted some crust. But yeah, a super interesting meteorite, very, very fragile. Easy to, if I stepped on this, it would go to powder. So its pyroxene and oxygen isotopes suggest a connection to, a possible connection to Vesta 4. And it has way more plagioclase than any diagonite, which is what it would plot next. You can see there's lots of big crystals in there. So that's one thing you've noticed about when we went from chondrites to achondrites, is there's a lot more metamorphism that goes into the piece, whether it's heat and pressure and water or geological processes on a bigger body. So that is my piece of Widmanstätten. This one is easy to name. This is, well, easy to identify, hard to say sometimes. Haciel Biode 002. Now, this is a palisite, so we know what class it is, but we can't group it. It's not the main group. It's not a Eagle Station or anything like that. It is an ungrouped palisite. Now, that's due to the unusual magnesium-rich olivine, and also the oxygen isotopes do not match established palisite groups. So that's why it's put in a unclassified state. This is about 60%, not this exact sample, but according to the METBUL, the Meteoritical Bulletin Database, 60% metal, 38% olivine, and 2% trollite. So I'd imagine maybe that black would be the trollite. I don't know. Something to talk about. This contains small amounts of pyroxene, making it possible that it's a pyroxene palisite. But the metal in it tracks back or closely correlates to that of a 2AB meteorite group. So could this be a silicate-bearing link to the 2AB group? And that's kind of why the ungrouped really appeal. Not just because they're this beauty. They appeal because they ask so many questions. And they're the missing link maybe between groups. And if we only get enough, we'll have a complete story to tell. Well, we are going to continue the conversation without recording. We never ever want to give out bad information, and we're right on the edge of our comfort level. We're past my comfort level, but we're on the edge of what science is starting to understand and starting to classify. And so we can forgive ourselves for not being the most intelligent sounding group today. We tried our best. We're discussing topics that are a little bit over our heads. We're trying to do our best. We appreciate you coming back week after week for your meteorite education here. Like I said, we are going to stop recording now, but we're going to get down and dirty in the science between us all. So thank you very much. One last reminder, we have a Patreon. You can sign up as a paid member or as a free member. We have like 400 people, 300 or whatever are free, so join us there. Sue is pretty active there. She spends a lot of time replying to people, interacting, putting up quizzes, educational stuff, rock IDs, challenges, interactive stuff that you can't do here on YouTube. So we do appreciate you guys joining us every week. The crew and I, we all send our love. Thanks a lot, and we'll see you next week.